In this video, we're going to look at some of the methods built into Java in the math class for rounding numbers. And there are lots of different ways to round numbers. There's traditional rounding, but there's other ways as well. And we're going to talk about some of those methods. And the first thing I'm going to start out with is math.ceil, which is ceiling. So this is a way that sometimes it's confusing for people to remember these, but I like to think in terms of a number line. Positive values to the right. As we move to the right, things get larger. As we move to the left, things get lower. Okay, so math.ceiling, basically, let's pull it over the documentation for that. Math.ceiling. It returns the smallest, closest to negative infinity, double value that is greater than or equal to the argument and is equal to a mathematical integer. Okay, so it's going to go up to the next integer, even though it's going to return it to us as a double. It's going to be something 0.0. So the next value that is greater than or equal to whatever we pass to it. So I always like to think of it as it's always rounding up. Okay, but you got to remember, with negative numbers, rounding up can take you to smaller digits because you're moving to the right. So -2, you round up to something that's between -2 and -3. Rounding up means taking it up the timeline to the right. It would become -2. So let's look at the examples. Okay, math.ceiling 2.1. We're going to go up to the next integer. The ceiling says we always go up, so it should give us a 3. Let me comment out these other ones real quick. And we do. We get 3.0. So again, it returns us a double, but it rounds up to the nearest double that's equal to an integer. So it's going to be 3.0. Okay. So ceiling 2.0, since it's right on, shouldn't do anything. And we get 2.0. Okay. But now let's do the negatives. Again, 2.0 is right on and equal to an integer, so it won't do anything. It just stays -2.0. But what about -2.1? It's going to go up or move. It's going to move right on the number line up to the next integer. And the next integer moving up from -2.1 is 2. Okay, so it moved up to the right, moved to the right on the number line, moving up the scale to greater values, so we get 2.0. All right, so that's ceiling. So if ceiling always moves to the right on the number line, it moves up the number line to the right, math.floor does just the opposite. It moves down the number line to the left. Okay. So it's always moving towards the smaller distance, the smaller way on the number line. It's always moving more negative. So 2.1 is going to come down to 2. 2.0 won't do anything. Neither will -2.0 because they're already equal to an integer. But -2.1 is going to move down to the left. It's going to move left on the number line. So more negative, and it's going to go to -3. So let's do those and test them. So there we go. 2.1, move to the left on the number line to the nearest integer, 2.0. 2.0 isn't equal to it is equal to an integer, so it didn't do anything. -2.0 is equal to an integer, so it didn't do anything. -2.1 moved left on the number line till it hit the next integer, which is -3. All right, let's comment those out. And let's look at this next set with this, which is rint. Why did I not get all of those? There we go. All right, so how does rint round to the nearest integer? Basically is what this does. So this is rounding to the nearest integer value. This rounds to the double value that is closest in value to the argument and is equal to a mathematical integer. So it's still going to return to us as a double, so it's going to have a .0 on it. but it's just going to the closest in value. And this is using traditional rounding. Anything 0.5 or above moves up to the next higher number. Anything below 0.5 moves down. But that's also true on the negative numbers. So the negative numbers, we're not always moving right and left, because when it's negative, we're moving the opposite way. So this is traditional rounding, just like you learned in grade school. So 2.1, the nearest whole number, 2.0. 2.0 stays 2.0. Negative 2. This one stayed negative 2. Negative 2.1 got rounded to 2. It's the closest integer. So we're always going to the closest integer. We're not always going to the right. We're not always going to the left. We go to the nearest integer regardless of whether we're moving up or down the timeline. 2.5, we got 2.0, and negative 2.5, we got negative 2. All right, so this might seem a little strange. 2.5 you would think would go up to 3. I misspoke a little bit earlier when I said this is traditional rounding. 2.5 is equidistant from 2 and 3. So rent, when we do rent, it actually looks for the closest even number in this case. So in this case, the closest even number would be 2, not 3. So when it's a tie like that, it goes to the nearest even number. So this is a little bit different than rounding. If I go even slightly higher, if I make this 2.51, it'll go up to 3. All right, but when there's a tie, this rent method actually goes to the closest even number. So what if this is 1.5? Okay, would it go down to 1? Nope, it goes to the closest even number. So it's still going to go up to 2. All right, so that's a little different rounding than we're probably used to. The only thing that's different about it, though, is when we have this tie condition. All right, down here, we're going to talk about math.round, which is more traditional. So let's go ahead and take a look at that. And you can see in some of these, we're putting in floating point numbers. And let's take a look at the docs. Okay, and go to the rounding methods. And you can see we have a couple different ones. Rounding with doubles as the parameter, and rounding with floats. So one of these, if we pass it a double, it's going to return a long. If we pass it a float, it's going to return an int. So returns the closest long, which is still an integer data type, to the argument with ties rounding to positive infinity. So in this case, the 0.5 will move up. Okay. Return the closest int to the argument if we pass it a float with ties going to positive infinity. So this is traditional rounding that we're used to. Let's do this and take a look at them. So 2.6 as a float gets rounded up to 3. And notice these don't have decimals on them. Okay, so they're integer data types. Okay. 2.0, when we round it, it stays to 2. Negative 2.0 as a float stays negative 2. And negative 2.6, because this is greater than 5 there, gets rounded to negative 3. So that's traditional rounding. So we covered 4 different methods of rounding numbers. We did ceiling, we looked at floor, we looked at rent, and we looked at round.